Welcome back to another edition of your favorite 7th grade math class. I am your teacher, Miss Donovan. This is my YouTube channel. If you don't already like and subscribe, you don't have to because I really don't care. But if you want to go ahead and do that, you are more than welcome. This is going to look a little different. I had a whole PowerPoint and I don't think it's saved, so I'm just going to do the lesson from here for today. So in this next chapter, we are going to do operations with integers. We're going to add, subtract, multiply, and divide with integers. And if you don't know, an integer is positive and negative whole numbers. So negative 1, negative 2, negative 3, so on and so forth. Whole numbers though, so no decimals, no fractions, just positive and negative whole numbers. And football is a case where you might see negative values because in football you can either gain or lose yards. Hopefully if you're on the offense, gain. If you're on the defense, you can make them lose. But you can have positive yards or negative yards that count towards getting your first down. So we are going to look at how we can use algebra tiles to model integer addition. If you don't know what algebra tiles are, we're going to look at those right now. So if we want to add, oops, I skipped too far, sorry about that. So if we want to use algebra tiles to model adding integers, we're going to use these yellow tiles to be a positive integer, and the red is going to be a negative 1. Okay, so if we want to model negative 2 plus negative 3, then I would add 2 negatives, so negative 2, and then plus negative 3 would be 3 negatives. Okay. So what would the solution then be? If I have negative 2 plus negative 3, can you guys see that this would equal negative 5? And if we have negative 5 plus negative 2, then what does that equal? But negative 7. Now, when a positive algebra tile is paired with a negative, we have a positive and a negative, we call that a zero pair. So zero pairs can be removed from a workspace because we don't really need them. So let's watch this and learn about zero pairs.
Using algebra tiles. Positive 1 tiles are yellow and negative 1 tiles are red. A pair consisting of a positive 1 tile and a negative 1 tile is called a zero pair. The tiles cancel each other out to result in a value of 0.
So anytime you have a zero pair, we can just get rid of those and see what's left here. So let's look at an example of that. If I want to add 3 and negative 7, so I have a positive 3 and we have negative 7. So I have 3 positives, 7 negatives. Then can you see here that, let me see, where's my pen? I should have a pen. I don't know where it is. Okay, so this would be a zero pair, this would be a zero pair, this would be a zero pair. Not sure. I'm not able to see. Okay, those would cancel each other out, and what we have left is 4 negatives. So 3 plus negative 7 would be 4 negatives there. If we want negative 5 plus 7, so 5 negatives plus 7 positives, and you could see that all of these would equal 0, and our answer is two positives there. So we're going to look at all these different ways of adding integers, positive and negative, but we're going to start with integers with the same sign. So to add two integers with the same sign, we can use number lines if we want to. So if we want to add -3 plus -4 on a number line, then we would start at 0 and move 3 units to the left because it's -3. So we're going to go to -3 and then move 4 units left to model adding the negative integer -4. And if we add -3 and -4, then we end up at -7. We could do the same on a vertical number line. So if we start at 0 and we want to add -5 plus -4, then we'll go down to -5 and then go down further, -4 more, and we end up at -9. So on page, I think it's 138 in your books, you guys can follow along on page 138. There's some blanks to fill in at the top there. Maybe it's 128. I think it's 128. The number line illustrates the rules for adding two integers with the same sign. So to add two integers with the same sign, add their absolute values. And the sum is, you can fill this in the blank, positive if both integers are positive, and negative if both integers are negative. So if they are both positive or both negative, you're just going to add the numbers together. And the answer will be positive if they're both positive and negative if they're both negative. So let's just look at an example here. And we're going to keep this simple here. If I want to add -7 plus -2, since these are both negative numbers, okay, we can use a number line. We can start and place -7 and then add on to that. Oops. No. Add a -2. Let's see. No. Press add once. Oh, this one's not working quite proper. Oh, there we go. Okay. And then it adds -2. There we go. So the 7 and then the -2 to equal -9. You can also just use the absolute value. So -7 is 7 and -2 is 2. So the sum of their absolute values is 7 plus 2, or 9. But then, since both of these are negative, then the answer is not going to be +9, but it's going to be -9. So if we want to do this check problem, this is our next example here. If I want to add -5 plus -11, -5 plus -11, since they have the same sign, I'm just going to add those two numbers together. But since they're both negative, my answer will be negative. Okay? So same thing here. Here is, if I have -8 plus -9, these are both negative, they have the same sign, so all I have to do is add those two numbers together. 9 plus 8 is 17. But since they're both negative, my answer is -17. Now you might see addition, but also figuring out what numbers to add together using word problems. So here, Allie borrowed $139 from her parents to purchase an ebook reader. During the first month, she purchased $47 in apps, games, and movies, which was added to the amount she already owed her parents. What integer represents the amount of money Allie had at the end of the first month? So, think about this. If we're talking about borrowing and spending money, would we have a positive or negative integer? Okay. If she borrowed money, then we're going to say that she has negative $139 because she actually doesn't have that money. She has to pay it back. And then she spent another $47. So if we add those two amounts together, adding those two together, the absolute value would be 196. Oops, no. 186. Okay. But because they're both negative amounts, then the answer is going to be negative. So negative 186 means that she actually owes $186 here. Let's look at another example. Sydney is shopping for her friend's birthday party. She withdraws $37 from her checking account to spend on food. She then withdraws another $18 to spend on party supplies. So she's subtracting 37 and then subtracting another 18. So she really has negative, her checking account went down by $55. So it's a negative $55. All right, the last thing we're going to look at for today is finding additive inverses. The integers 4 and negative 4 are opposites. Opposites have the same absolute value, but different signs. Two integers that are opposites, we call them additive inverses, and their sum is 0. So 4 plus negative 4 is 0. Okay, so let's look at the additive inverse property, which you should be familiar with. The sum of any number and its additive inverse is 0. For instance, 4 plus negative 4, which is its additive inverse, equals 0. And in terms of algebra, this works with integers, but also with variables. A plus the opposite of A equals 0. So this will become important when we start solving equations in a little bit. But an additive inverse is just the opposite of a number. They have the same absolute value, but different signs. So if an integer is negative 1, then the additive inverse is 1, and the sum is 0. If my integer is 2, what's the additive inverse? Think about it. Negative 2. If I add these, we get 0. If I have negative 3 as the additive inverse, then that means the integer is what? That's right, 3. I'll pretend I'm actually hearing you guys say it. If my integer is negative 4, additive inverse would be positive 4. Add these two, we get 0. You guys get the picture by now that the additive inverse is just the opposite of the number. And if I add an integer with its additive inverse, we always get 0. Okay? So to find the additive inverse, this one's kind of appropriate for here when we're talking about hiking and elevation. A hiking trail begins at an elevation of 150 feet above sea level. It leads down to the shore of the ocean. This is like a baby hike, which has an elevation of 0 feet above sea level. What integer represents the change in elevation from the beginning to the end? So think about it. If I start 150 feet up and then I end up at 0, then my additive inverse is going to be negative 150 feet. Okay, so 150 feet plus negative 150 feet is equal to 0. So the change in elevation, we go down 150 feet, so that's why it would be negative 150, if that makes sense. Last one. Again, if we want to find the additive inverse, Jaden's bank account is negative $13. How much does he need to deposit to bring the account back to 0? So negative 13 plus what equals 0? Well, we said that negative 13 plus its additive inverse, which would be positive 13, will give us 0. So we will stop with that for now. Try the check problems in this first part of section 3.1. Make sure you guys understand how to find the additive inverse and add integers that have the same sign, and then we will look next time and integers with different signs. Okay, that's all for this video. Comment down below if you have any questions that you want to talk about, and I will see you guys next time. Later.